Hello students, this is Dr. Siva Nagaraju from IARE. Today we are going to discuss about the spread spectrum modulation, and in this spread spectrum we are seeing the direct sequence spread spectrum and CDMA using DSSS. So these topics we are going to discuss in this session. Previously we come across different types of modulations, digital modulation techniques, all are covered. So in digital communication, the main goal is the efficient utilization of the spectrum. That means efficient utilization of the bandwidth. So in previously we seen in that way. Why? Because in the modulation techniques we are having binary and IARE techniques are there. Whereas in binary, we are sending only one bit at a time. Whereas in IARE, we can send more than one bit at a time. So here the efficient utilization is seen in that two techniques. Comparing these two techniques, binary and IARE, then we can conclude IARE is useful for sending more bits at a time. What the spectrum duration increases. But in this concept, we are going to provide a secure communication. So that is the main task of this spread spectrum modulation. Okay. Coming to the course outcome, actually this course outcome comes in the module 5, and the outcome is identify the importance of spread spectrum techniques for secure digital communication systems. For secure digital communication systems. So the spread spectrum is mainly for the secured communication. So that also is in digital. Okay, let us start spread spectrum. Spread spectrum refers to a system originally developed for military applications to provide secure communications by spreading the signal over a large frequency band. That means here the secure communication is required for some fields. In that, the military is the first one. So the military officials' conversation is very secrecy. So for that, we are going to provide some secure communication. So in that way, we are using this spread spectrum. How the spread spectrum is done? Here we know the spectrum. Spectrum means nothing but frequency bands. The range of frequencies, that is called bandwidth. So the spectrum which deals with the frequency bands. So the spread spectrum, the name reveals spreading the spectrum. So here, how to provide secure communication? By spreading the signal over a large frequency band. So that is spread spectrum. So in technical you can say spread spectrum is a technique whereby an already modulated signal is modulated a second time in such a way as to provide a waveform which interferes in a barely noticeable way with any other signal operating in the same frequency band. So our aim is we are going to spread the spectrum. So how the spread spectrum works? It is going to modulated, already modulated signal. So that means a double modulation is done in this spread spectrum. You can say simply double modulation is going on. Okay. So by the spread spectrum, our aim is our signal not identify easily to any other one, like that interferes one. Okay. So in this figure, here the narrowband signal is there and the noise level is also there. So in this figure represents a narrowband signal in the frequency domain these narrowband signals are easily jammed by an other signal in the same band. So likewise, the signal can also be intercepted since the frequency band is fixed and narrow. So it is easy to detect. It is easy to detect. So narrowband means the band of the signal is very narrow. So our aim is to spread this like this. I'm going to spreading like this. So I'm spreading. So I'm going to spread my signal into a wide. So there is wide spectrum, a wide range. So I'm spreading the spectrum. So that is a spread spectrum. So in another sense, you can say I'm going to bring the signal into the noise. That is also very difficult to any intruders or any interferers to detect. So our aim is not easily to detect the signal. So that is a spread spectrum. So that's why we are going to provide the secure communication. No one is going to interfere into our band. Here the band is not known. Why it is very spread? If it is a narrower, the who are interfere or who are to jump or who are to hack, you can easily identify if it is a narrow band. If it is wide band, it is more difficult to interfere or hack this signal. So what are the advantages of the spread spectrum? Reduced cross-talk interference. So reduced cross-talk interference means here the interference is going to reduce. Why? Here we are using some pseudo noise sequence for this spread spectrum. So it gives security and it also reduces the interference and better voice quality and less static noise. That is another advantage, and lowered susceptibility to multipath fading, inherent security, longer operating distance, hard to detect. So these are the main advantages of this spread spectrum. Okay. So this is a general block diagram of this spread spectrum. So here you can see the input message is applied to channel encoder, and then after it is going to modulator. So in the modulator, we are using the spreading generator. So the spreading generator is nothing but this is pseudo noise. This pseudo noise, that is you can say as a PN sequence simply. The PN sequence generator is again modulating the already modulated signal. Here the double modulation. So first the input modulation, input signal is going to modulate it, and again we are going to modulate it by using a PN sequence. So already know that modulation. Modulation means this is a process by varying this characteristics in accordance with the message signal. So that is already know that modulation. So in the first modulation we use the carrier signal for modulation, but in the second modulation we use this PN sequence, pseudo noise sequence for modulation. Then we are going to transmit the signal to the channel, and again in the receiver side we are having the demodulator, spreading, despreading generator, and a channel decoder, and finally we are getting this signal. Okay, so this is a despreading generator. One is spreading, another is the despreading at the receiver. So this is totally is nothing but a transmitter, and this whole block is going to the receiver. Okay. So here are two techniques. What are that one? There are two predominant techniques to spread the spectrum. So by using these two techniques, we are going to spreading. Okay, that means we are going to broadening this spectrum simply. So the first one is a frequency hopping. The frequency hopping, which makes the narrowband signal jump in a random narrow bands within a larger bandwidth. That is a frequency hopping. Whereas second one is a direct sequence. So direct sequence which introduces a rapid phase transition to the data to make it larger in bandwidth. So these are the two dominant techniques we are going to spreading. So in this session, we are going to deal with the direct sequence. In the next one, we are going to frequency hopping. Okay. So the first one is the direct sequence spread spectrum, simply DSSS. So the direct sequence spread spectrum introduces rapid phase transition to the data, make it larger in bandwidth. So rapid phase transition to the data. So that is the direct sequence. So as the period t of signal gets shorter in time, or data rate or increases, the bandwidth of the signal increases. So r equal to 1 by t, that is equal to 2b. So b is the bandwidth of the signal. So that is nothing but Nyquist rate. So here r is the rate which is directly related to the period of time, that is 1 by t, inversely proportional to the period of time. R equal to 1 by t, that is nothing but Nyquist rate 2b. So in this picture, we are having transmitter and receiver. So in this transmitter, we are having the binary data sequence that is applied to the NRZ encoder, that is a polar NRZ encoder, and this encoded signal B of t is applying to a modulator, that is a PN code generator is there, C of t, and the producer signal M of t is again modulated by using a PSK. So here we are using this double modulation. So here this is one type of modulation, that is you're going to multiply this message signal or encoded signal with the PN sequence, and again I am going to modulate by a PSK modulator, BPSK. So already you know that BPSK we covered across in the previous topics. So the PSK modulation just multiply this message signal M of t into the carrier signal C of t, then produce some X of t or S of t, whatever it may be. So this is the modulated signal. This is the modulated signal. So this is a transmitter block diagram. We are coming to the receiver. So here you are using the coherent detector. Why? Binary phase shift keying. So the transmitter I am using the binary phase shift keying, where here in the receiver I use this coherent detection. So coherent detection means already we discussed it. So the same phase information can be used to recover the message signal, then we can call as the coherent detection. So here the coherent detection is used with the local carrier. So this local carrier is same as the carrier what we use in the transmitter. That is the coherent detection. So Y after is the received signal. So it is applied to the coherent detector. So in this coherent detector, we are having the protect modulator, low pass filter, and then again going to apply this local PN code generator. Why? The transmitter also uses PN code generator. So the same I am using, whatever using the transmitter, same as using the receiver. So then why I can this despreading is done. And then after I am going to apply this integrator and decision device. So the decision device may have the threshold. So if the threshold exceeds, then you can call as 1. Not threshold exceeds the threshold level not exceeds 0, then it is called as symbol 0. Okay. Why? This is digital, only having 1 and zeros. So that is easy to make a decision. Now about the transmitter first converts the incoming binary data sequence BK into an NRZ waveform, is nothing but B of t. So NRZ means non-return to 0. So non-return to 0 means, for example, this is 1, 0, 1 like that. So this is a binary data sequence, and I'm going to now return to 0. So this is my now return to 0. This is 0 level. So in this way, so this is B of K and this is B of T. This is N of Z. Okay. So after we followed the two stages of modulation. So the first one is the X of T has two phase values 0 and pi depending on the polarities of message signal B of T. Why? Because so here I'm using the PSK phase shift keying. So phase shift keying provide 180 degrees phase shift for symbol 1 and symbol 0. So that's why here taken as 0 and pi. So depending on the polarity of the message signal. So for the positive polarity 0 and negative polarity providing pi. Okay, why? Because previously we've seen that B of T is an NRZ level encoder. So the NRZ level encoder having only either positive or negative. There is no DC level. Okay, and then PN sequence. It is a pseudo noise sequence signal C of T at a time T in accordance. Okay. So why? Because in the transmitter we are having two modulations. One is modulation with the carrier and another one is modulation with the PN sequence. So double modulation gives the spreading of the spectrum of the input signal. So that is our aim. Narrow band is easy to interfere. So that's why I am going to wider or broader the spectrum. Okay. And coming to the receiver consists of two stages again as in the transmitter. So the receiver consists of two stages of demodulation. In the first stage, the received signal Y of T and a locally generated carrier are applied to a protective modulator followed by a LPF, low pass filter. And this stage of the demodulation process reverses the phase shift keying applied to the transmit signal. So why? Because here the last stage of the transmitter is PSK, phase shift keying. So phase shift keying provides the phase shift of 180 degrees. So that is removing the phase values of the transmitted signal. And the second stage of demodulation performs spectrum despreading by multiplying the LPF output by a locally generated replica of the PN signal C of T followed by integration over bit interval 0 to TB and finally decision making. So that also seen in the receiver block diagram. Okay. So what you done in the transmitter, the reverse operation is done at the receiver. So in the transmitter, I am going one time by using carrier and another time I am using this pseudo noise sequence. By using these two, double modulation is done. Whereas the receiver also the same operation. First the PSK is removing and then after this PN sequence also removing and finally what I am sending at 1 and 0. So again reproducing this symbol 1 and symbol 0 by using this decision making. So decision making is we have a threshold already discussed. So the threshold is compared with the threshold level. So generally taken the threshold level as 0. So the threshold level exceeds, then we can make in favor of symbol 1. If not exceeds, make decision in favor of symbol 0. Okay. So this is a simple block diagram is given. So here you can see B of T. There is my NRZ encoder signal and then is applied to the PSK. So binary PSK modulator. So here this is the first modulation and the second modulation is this by using PN code generator. Okay. So B of T is multiplied with the carrier C of T, produces S of T, and those S of T is a modulated signal and the modulating again modulation by using this PN code sequence generator. Then the final thing is X of t, and it enters into the channel. So always in the channel, what adds up? Simply the noise will go into adds up. So the received signal is a noisy signal. So the noisy signal we can call as Y of t, and this Y of t is applied to the receiver, first stage, and another is the second stage, and final is the estimation of B of t. So that is the decision making device. Okay. So now CDMA using DSS. So code division multiple access is a digital cellular network standard that utilizes the spread spectrum technology. So CDMA using this direct sequence spread spectrum. So all signals use the entire allocated spectrum, but the spreading sequences or frequency hopping patterns differ. Okay. So the basic concept in CDMA is that users who wish to communicate through it are given a shared code. While multiple codes may occupy the same channel, only those users having the same code can communicate with each other. So already we know this CDMA. CDMA is nothing but a multiple access techniques. Previously CDMA were having FDMA, frequency division multiple access, then after TDMA, time division multiple access, and finally CDMA. So you know that in FDMA the entire bandwidth is divided by n users. So each user is allocated a frequency. By using that frequency, that user is going to communicate. Whereas in TDMA, the time slots is available. So in that particular time slot, that user is going to communicate with each other. So now CDMA. So CDMA uses the codes. So it is given a shared code. By using the shared code, the users which having the same code, they can communicate with each other. So that is the basic concept of CDMA. So another major CDMA advantage exists in networks accommodating voice communications. So CDMA is present using maximum people. Okay, and but 80% of users are GSM. Okay, so that is dealing with the cellular mobile communications, but not coming to the digital communications. Okay, and the two principal types of spread spectrum CDMA are direct sequence CDMA and frequency hopping spread spectrum. But in this syllabus, we are having CDMA with CDMA using direct sequence. So that's why we are discussing about this CDMA with the direct sequence. Okay, frequency hopping also there, but in that syllabus, so that frequency hopping is not there. So that's why we are discussing about CDMA direct sequence spread spectrum. Okay, and what are the advantages of this CDMA? So CDMA offers more airspace capacity than the TDMA, time division multiple access, based on GSM standard, global system for mobile communications. Why? But 80% of the world using GSM, that is TDMA based GSM. But what are the advantage than this GSM by CDMA is more airspace capacity. Okay, and second one is CDMA also uses less power. So there is a very big advantage. Why today power consumption is very important. So CDMA uses less power. Okay, another advantage boosted by CDMA technology is stability for soft handoffs between base stations. There is less likelihood of cut-off calls. So handoffs. So again, this handoff technology is dealing with cellular mobile. Why? We already know that how the cellular mobile operation is done. So cellular mobile communication is based on the cellular cells. So cells is nothing but a base transceiver system is covering area. That means simply you can talk with tower, cell tower. So the cell tower provides a range of communication in that area. So that is called as cell. But cell is generally in the shape of hexagonal. So when the user is moving from one cell to another cell, so the cell tower, that is a BTS, makes a request to the another cell tower. The some X user is moving from one cell site to another cell site, so provide the signal to that user. So there is a handoff. So why? Because at the border of that cells, the signal is weak and interference is increases. So at that time, the C by I is going to reduce. So the call may be cut off. The call may be cut off. So we should maintain a good C by I is 18 dB. 18 dB. So if 18 dB is less, or it is going to reducing that 18 dB, immediately that base transceiver system is going to communicate with the BSC, base station controller. So the base station controller controls a number of BTSs. So BTS is nothing but cell towers. So it's just like this one. So this is my cell. So the center one is cell tower. So the user may rotate around this cell. So and the user can move from one cell to another cell. So like this. So this is the border. So in this border, this 18 dB C by I is going to reducing. So the call may be cut off. So for any good telecom company or operator must provide without interruption of the call. So the call doesn't cut. So it is going to uninterrupted communication must and should provides. So that's why the BTS duty is it is going a request to another BTS. Such user is moving from my location to your location. So we must provide this signal. So this is all controlled by this base station controller. So there is a soft handoff. So that means we don't know such operation is going on. We are moving from one tower to another tower, but we don't know. So that duty is done by BTS. So such type of handoffs are easy in CDMA. So that's what I'm saying. The CDMA technology is its ability for soft handoffs between the base stations, so that a user doesn't identify when this total job is done by this BTSs or base stations. Okay, and references. So here the total content of this information is taken from Simon Hacking, third edition, and again digital communications by Simon Hacking. So that also considered, and some web pages are also referred for this delivery of this content. Okay, thank you.
Like, share and subscribe. Hit the bell icon for more updates.